Hello YouTube, in this video we're going to be exploring how to use a 3x3 system to solve for practical application problems such as investments or finance. Okay, let's go ahead and start by reading through the situation. We have an inheritance of $12,000 that was invested among, not a month, but among three funds. Okay, so we have a money market fund that paid 5% annually, municipal bonds that paid 6% annually, and the mutual funds that paid 12% annually. It says the amount invested in mutual funds was $4,000 more than the amount invested in municipal bonds, and the total interest earned during the first year was $1,120. So we want to know how much was invested in each type of fund. We'd like to start by saying this. In terms of solving a 3x3 system, of course, we have three funds here. The amounts that we're looking for, let's just put it this way. You should always read the last sentences. Typically, that's what will ask you what you're solving for. Okay, so like that's what will state what you were solving for. So in this case, it says how much was invested in each type of fund. What we're going to do is we're going to make those the unknowns. And since we talk about each type of fund, well, we had three funds. We had a money market fund, we had a municipal bonds fund, and we had a mutual fund. So the very first thing you need to do when you solve a practical application problem such as this one is define your variables. We're going to start with this. We say let x equal, y equal, and z equal the unknowns that we're looking for. Just by reading the last sentence, you can typically tell these things. So we say number of. Now you notice I wrote number of on each of these. If you don't write number of, we say dollars in this case. If you just say let x equal the money market fund, then you're literally calling the letter x a money market fund, and that's not what we want to say. We say number of dollars invested and money market. So we say money market fund. We're going to tell our audience this, money market fund. We also want to say that we just call Y. We go right down the road here. We can say municipal bond, so number of dollars municipal bond. I'm just going to write municipal. And then the last one here we say we have a mutual fund. So we say number of dollars in the mutual fund. Okay. So now that we've defined our variables, what we need to do is construct our system using what we know. Okay, so one thing I do want to point out is this. You usually look for equations that involve like totals. And so we say, well, first of all, if I were to add x plus y plus z, that would be the total amount of money. And we actually know the total amount of money. But we're going to say dollars plus dollars is dollars. In this case, we have amount invested in our money market plus the amount invested in our mutual fund plus the amount invested in our municipal bonds, and then we say amount invested in the mutual fund is $12,000. So this constitutes one of our three equations, and it's probably the primary equation. The second piece of information that was divulged to us is it says the amount invested in the mutual funds. Now, looking at the way we define our variables here, we say well, this is represented by z. But what we know is that z is actually 4,000 more than the amount invested in the municipal bonds, which is represented by y. So we're just going to write this out very literally. We say z is, that is z equals 4,000 more than the amount invested in the municipal, which is y. So we say y plus 4,000. Okay, so here's our second equation. And we say that the last equation comes from this last number down here, 1120, which involves our total of our interest. Okay, so when we say interest, well, what we know is this. We had 5% in our first fund interest. That is, for every dollar we spend, we get 5% of that on top of what we invested. And then we say 6% annually. That means at the end of the year, whatever we invested there, we get 6% of that back. And then 12% on our mutual fund, whatever we invest there, we get, every dollar we spend, we get 12 cents on the dollar, on top of what we had invested. So the important thing here is this. When we write this equation, it is also another totals equation. We say, and it's going to come out to be $1,120 worth of interest. But when we write this, we have to convert these percentages to decimals. So recall that if I said like 5%, 5% is this 5.00%, like this. But we can convert a percentage to a decimal by shifting our decimal twice to the left. So this would become 0.05. So that being said, I'll kind of quarantine that there. We say we have this then, 0.05x plus 0.06y. I'm trying to squeeze all this in here. It's probably not very wise. Plus 0.12z. Okay, so in other words, 5% times every dollar we spent in x plus 6% every dollar we spent in y and 12% of every dollar we spent in z adds up to $1,120 worth of interest. We are going to modify this system in a couple of ways. As a matter of fact, it would be wise for us to put these all in what we, I guess, would call standard form, in which all of our variables are on the left side, all the constants on the right. This is a particularly good way to solve a system. So this here, we're going to bring our y back over to the left. In the last equation, we're going to take the whole thing times 100. What that's going to do is going to convert these values on the left to integers, or shift our decimal twice to the right. So now we get this new row equivalent system in which we said, okay, well, our first equation, that's not going to change. X plus y plus z equals 12 grand. And then the second equation, we brought y back over to the left, so we have negative y plus z, and this was equal to just a plain old 4 grand. And if we took the last equation times 100, we'd have just 5x plus 6y plus 12z, and this would be our original 1120 plus 2 more zeros following. Now, from this point, we can actually go through and solve this system using what we, I guess, call Gaussian elimination, in which we're trying to put this into what we call row equivalent form. That is, this form in which we have just this kind of stair-step fashion in which our leading coefficients are 1 at the beginning of each row. Okay, so you'll notice that the x up in the top equation here already has a coefficient of 1. Our job is to make everything underneath this into 0. So we already are missing the x value on our second equation. We're going to get this x value on our third equation to cancel out by doing this. We say, well, since we already have a coefficient of 1, if I could make that into a negative 5 and add it onto the third row, it would cancel out with my positive 5x. So our row operation is going to be this. Negative 5 times row 1, we're going to add that onto row 3. So now up top we get this new system. We have x plus y plus z is still equal to 12 grand. We still have our second equation of negative y plus z and being equal to 4 grand. And our third equation, now the x's are gone. We said, okay, so well, negative 5 times this top y here would have been negative 5y. Negative 5y plus a positive 6y would have just been y. When we say negative 5 times this top z would have been negative 5z plus our 12z here would have been 7z's, 7z. Okay, and this would have equaled, negative 5 times 12 grand is negative 60 grand. Negative 60 grand on top of this 112 grand here. Negative 60 and 112, let's see, negative 58 or positive 58,000, 58,000. 58,000. I've done problems like this before. I just want to make sure I'm right, and it's never a bad thing. 112 minus 60. 52. See, we would have had a bad day if we had done that. So 52 grand, and I should know better. So 112 minus that 60 up top there is 52 grand. Okay, so now working with this, we say, okay, so now these x values here are gone. We want to work on getting this now leading coefficient of our second row to be 1. So what we can do is we can say negative row 2. Just multiply the whole thing by a scalar of negative 2. So we have x plus y plus z is 12 grand on top. We say a positive y minus z equals negative 4,000 now. And our last equation is y plus 7z equals 52 grand. Okay, so now that we have a 1 here, we're going to make everything underneath it 0. This can be done by taking negative row 2, and adding it on to row 3. So now our new row equivalent system becomes x plus y plus z is still 12 grand up top. We have y minus z is negative 4 grand on our second equation. Our third equation now becomes this. We say, well, negative 1y plus 1y is 0. We say negative z is a positive z, and positive z plus 7z is 8z, 8z. And then we say negative 4,000 plus this 52,000 becomes $56,000. So now this last equation, we're going to do 1/8 of our row 3. And so this will put us in complete row echelon form. X plus y plus z equals 12 grand. We have y minus z equals negative 4 grand. And then our last equation just becomes an individual z. And we say an eighth of 56 would be 7. So we say $7,000. So what we know is this. Z is 7,000. So we have this consistent system here in which our z value is 7 grand. What this interprets itself to be is this, though. We say we must have invested 7 grand of this into our mutual fund. Okay. That being said, we need to solve now for the other two values, so we're going to back solve by plugging this in up here. We say if I put in my 7 grand up here, we get this now, y minus 7 grand equals negative 4 grand. And if we add add 7 grand to the other side, we get y equals 3 grand. So now the amount we invested in our municipal bond fund was 3 grand. And now knowing these two values, we can plug that back into the top equation here, our y and our z here, and our y here, to solve for x. And we would have this. We'd say x plus 3,000 for our y plus 7,000 for our z equals 12 grand. And so really we say x plus 10 grand equals 12 grand, so our x must be 2 grand. But yeah, this is just a small example of how we would use this to solve a finance situation. Cheers.